Hi, hello everyone, welcome to this video. So last time we left off with our shadows, and this time we're going to do basically just we're going to program some ball velocity and then collision with the pedals. So let's get started with it. We can start with the ball. So for the ball, we just want to basically model kind of ball here, and we just want to move its position somewhere here or wherever, and then we want to collide it with the pedal and then bounce that position off. So the first of all, we have to model that ball. So we're going to have this idea of a velocity, right? And so we're going to have vector velocity, and velocity is just going to be, in our case, actually let's call it direction. So we can just call it direction. It's going to be direction of our ball, and then we're going to multiply it by some speed to actually scale it up or scale it down. So it's just going to be, well, the speed. So we can say private var direction, and it's of types in the float 2, and then we can just say then 1. We're going to normalize it. So to normalize it means if our vector is like this, we can normalize it like this, and it's going to have this length of 1. So we're also going to have speed, and speed can be of type float, and we can set it to 0.1. I don't know, we're going to see values how they work. So we're going to have public function update, and we can move this to update actually. This setting up of matrices, we have position here, so we can model the position as well. So first of all, I mentioned that I want to normalize our direction. So it's in the normalize direction, and then we can just edit position.x plus equals direction.x times speed, and then the same for y. And let's see if it actually so I just need to get started with it. The speed might be too huge or too small, so it might move a bit slow or a bit too fast, and it seems it's way too fast. So I'll just try it again with kind of lower speed, maybe something like 0.01. You kind of have to tweak it a bit, since I'm not crunching any math here. I'm just assuming that it's going to be good, but it's not good. Maybe I did something wrong here. Position x plus 6. I never called update. Silly me. Okay, let's just go here and actually update the ball as well. So we can just say here ball dot update. So now it's going to move. So it might be too slow. Let's see. Yeah, it's kind of moving, but it's way too slow. You can probably see it moving. So I'm just going to do this again, and then let's just modify our speed, and this is way faster. So I think this will be okay. Yeah, it's okay. It just went off the screen. All right, cool. So yes, the first part is done. So let's model some collision rectangle that we can use to actually collide stuff. So here in our PONG, I'm just going to add maybe new group, collision, and I'm just going to create a new file, Swift file, and I'm just going to call it collision rect. So this is going to be very simple. So basically, the type of collision that we're going to do is called axis aligned bounding box collision, I think. But basically, the idea is we're going to have some rectangle, and then we're going to have another rectangle, right? So these two are not colliding, but if we have this and then this, we can determine that this region is overlapping, and therefore they're colliding. So why is it called axis aligned? Well, because we cannot have rotation, right? We have this axis, and then we have this axis as well, and we cannot rotate it, otherwise it will break. So this is going to be an important part of our collision, and how it works is basically we're going to check this x, then we can check ending x, right? And also we're going to check this x region and this x region. So this is just for the x direction, and then we can compare those regions and determine, okay, if this region is basically greater than this region, right? If this x is greater than this x, we can say, okay, we're sure that they're colliding, then we compare these two edges as well. Anyway, we're going to get to it as well. So I'm just going to say public x is of type float, and by default it can be 0. Public y is of type float, it can be 0. Public, I'm just going to say that will be for width, and public h for height is 0. And we can say public function collides. So we're going to pass another rect. So we can say other collision rect, and it's going to return bool, and then we can do our collision. So for our collision, what do I want to check actually? So let's get started, and here I forgot to add bars. So how will we do it? Well, we're basically going to have, let's just say here let x collision, and for that we're going to check if our x is less than other x and plus other width. So it means, let's try to break it. So it means if we have these two colliders, and let's say that they're overlapping. So what does it say? If this x, and let's say this is collider 1 and this is 2, or this is the other one. So if this x, right, x being somewhere here, right, all of this is x, if this x is less than other x plus other width, so it means this one here, right edge. So if this x is less than other x, right, so we can call this other x, we're going to have kind of collision, but we still need to determine this side, right? So let's do that. And so here we're just going to say if other x is less than x plus width, and that's our x collision. So what we're saying is, now we're saying if other x, if this x, right, here is less than this x here, or this side here. So we can see that here x is colliding, we can determine that, right? So here is our collision part. So then the same is actually true for y, right? So y collision, y is less than other y plus other height, and then other y is less than y plus height. And we can just return x collision and y collision. So both need to be true. Okay, cool. I'll just do this. Prettify it a bit, and that's it. Very simple. So we cannot find type collision in scope. I have some error, but I cannot figure out what's happening. Public. Oh, my bad. Collision rect. Okay, got it. Alright, let's go for our ball. So we can update that collision rectangle, and we can do that here. So our collision rect. Did I add it here? No, I still haven't. So I'm just going to make it public. Is of type collision rect, and we have our defaults. So here is a bit of a catch. So let's just get rid of this. So our objects in on our graphics card, they actually have origin here, but we want our collision rect to have basically origin here. So what I'm going to need to do is subtract half width, right, to get an x, and then the same is true, subtract half y and we get y right here, and then our width is just going to be x. Well, our width is going to be this. So we just need to subtract here. Collision rect is equal to our position x minus, then we need half width or scale. The text times 0.5 or divided by 2. You can do it either way. So then it's true for y as well. Position y minus scale dot y times 0.5. So what's our width? Well, it's just scale x, right? And then collision that height is scale height. Okay, so we have collision rect. We have I added this small method collides. So we can in our collides. Actually, let's go to our pedal. So I just need to basically copy this because it's going to be very similar in our pedal. So I can just update it here, and then we can just create collision rect. Can be equals collision rect. Can build it immediately. Here it's fine, it's fine, it's fine. I could have moved this as well to update. Alright, we have our collision rect. So let's go to our ball. And we can then check if collision rect collides pedal dot collision rect. We can just change direction dot x times equals -1 direction dot y. Does it make sense? Collision rect. So for start, let's just change x direction, and we're just going to need to check for those collision, and then we can run it and check if we have something. So we can just say ball dot collides, and then we have pedal 1, and then ball collides, and then we have pedal 2. Okay, I need to unwrap as usual. Alright, here we have our game, and they're colliding. So our ball is probably going to go out of bounds, and it doesn't have shadow as well, so we can fix that real quickly. Let's just finish that, and then we're almost done. Okay, for our ball, I want to have a shadow on it. So where is our shadow class? Here, it was commented out. But I never create. Okay, let's draw shadow, random pass encoder, then we need shadow camera here. And I probably don't have pipeline on our ball, so I forgot to do that last time. Let's do that real quick. And as usual, you can just copy paste shamelessly. And what do we need? We need shadow pipeline. Public. No, private. Shadow pipeline. Shadow pipeline. Where did we create a pipeline? Here. And then hit test device. Let's just see if it works. Okay, it has shadow. Perfect. We solved that. That was really quick. The other part that I want to solve is what did I want to solve? Yeah, I'm just going to hardcode some values here. So I'm just going to say if position.x y is greater than, what was it for the pedal? We had some limits here. Yeah, this. So I'm just making sure that it stays in bounds of the game. Okay, if it goes way up, I think it will bounce back in. It won't actually. So what we want to do is just set position y, but then we also can just change direction as well. Y. So with that said, this is pretty much complete. So I would suggest maybe to for you to actually improve this quite a bit, because I don't think this is really essential when it comes to graphics, which this course is all about. So I would just maybe adding some other directions, playing with speed. You can increase the speed when once it bounces off of other pedal. You can also try changing direction a bit with randomness or something. So I'm going to leave it to you. This was a very quick lesson. I just wanted to have some kind of gameplay, because next time what we're going to do is actually split screen, and then we're over with this series. So hopefully you enjoyed this video. If you enjoyed it, please maybe like, subscribe, leave a comment, and until next time.